Leaving Cert Higher Level Question 2 in 2019 dealt with an exponential function. You're asked to graph a linear function. You're asked to use substitution to verify something, and then you're given a proof by induction question. So quite a mix of things within the same question. So drawing the graph of the function, g of x is equal to 4x plus 1. If we look down at it, we're starting at 0 on the x-axis and going up to 2.5. So it might make sense to use those x values, 0 and 2.5. And you can see when x is 0, we're just going to be left with g of x or y being 1. And when x is 2.5, 4 by 2.5 is 10. So you're going to get 10 plus 1, which would be 11. So we draw this on the graph. We have the point of intersection here. We have 2.5, 11. So looks like it comes under it at some point, approximately here. And we can see in the next part of the question, you're asked to show, let's just look at the next part first. So the second part asks us to use substitution to verify that f of x is less than, so it's going to be underneath, g of x for x is equal to 1.9. So we go to 1.9, it's going to have to be above it there. So just make sure that when you're drawing your graph, it was given to you on a scale diagram of the leaving cert. So a ruler, you shouldn't get this question incorrect. Maybe check the endpoints and make sure you get this question fully correct. So using substitution to verify that f of x is less than g of x, we're putting in 1.9. So 3 to the power 1.9, is that less than 4 by 1.9 plus 1? So the right hand side gives us 7.6 plus 1, which is 8.6. And if we type the left hand side into our calculator, you're going to get 8.06. So you can say QED, quod erat demonstrandum, that yes, f of x is less than g of x for x equal to 1.9. So proof by induction to show this. So use proof by induction to show f of n is greater than or equal to g of n for n is greater than or equal to 2. So let's look at f of 2 is going to be equal to 3 to the power 2, which is 9. And g of 2 is going to be 4 times x, which is 2 plus 1, which is equal to 9. 9 is equal to 9. So yes, for n greater than or equal to 2. So now we just need to assume true for n is equal to k and write this down. Just get used to using the same process each time. Assume true for n is equal to k. So what are we going to get then? We're going to get 3 to the power of k, and our assumption always helps us in proving n is equal to k plus 1. So that's 4k plus 1. K has replaced x. Now we're going to show true for n is equal to k plus 1. So we're going to get 3 to the power of k plus 1 greater than or equal to 4 times k plus 1, which is 4k plus 4 plus 1, which is 4k plus 5. So we have to show that 3 to the power of k plus 1 is greater than or equal to 4k plus 5. Now, what do we know so far? We know that 3 to the power of k is definitely greater than or equal to that. We're assuming that. So if we break 3 to the power of k plus 1 up into 3 to the power of k times 3 to the power of 1, that will become 3 times 3 to the power of k. And using our assumption, which is what we want to do all the time within these proof by induction questions, if we replace the 3 to the power of k with 4k plus 1, we're going to get 12k plus 5. 12k plus 3, of course. 12k plus 3. And we can say at this point that if we look at these two things, 12k plus 3 has to be greater than 4k plus 5. And we write for k greater than or equal to 2. And we can see that if we put 2 into the left, we're going to get 24 plus 3 is 27. We're going to get 8 plus 5 is 13. And you could write that down if you wanted. 27 k equals 2, you're going to get 27 greater than, what do we say, 13. Just test the next one. K is equal to 3, we're going to get 36 plus 3, 39 is going to be greater than 4 3s are 12 plus 5 is 17. So therefore, it's true for k is equal to 1. Assume true for n equal to k. So just finish it off by saying therefore true for all values of k where k is greater than or equal to 2. So proof by induction, a question worth practicing.